All right. So running water, the first half of this. Um, and throughout these notes, if anything that says, river, uh, the the same, holds true for streams or creeks or babbling brooks or anything like that. So just you can kind of, apply that to other bodies of running water. Okay, so there are three ways that rivers move sediment from one place to another. So digging back, sediment was created through from weathering. As rocks break down. The first one is in solution. So if whatever the sediment is, it's some mineral that can be dissolved in water. Um, if it does dissolve in water and is moved from one place to another, that's one way that the sediment can be moved in solution. The next two, suspension, which it says float, which is kind of deceptive because whenever I hear the word float, I think of something, on the surface of the water, floating on the surface. It's not quite like that. Um, Suspension, just like, a suspension bridge, like the Golden Gate Bridge, the bridge is held up, or suspenders, hold up paints. This is where the sediment is kind of held up in the water because the water is moving. While the water is moving, it has kinetic energy, and that energy is enough to keep the sediment suspended in the water as it moves. Anytime that sediment or that water slows down or loses that kinetic energy, then that sediment will settle to the bottom. So if you were, to go to some river that's muddy and kind of dirty looking, and take a glass and get a glass full of that water and set it on a counter somewhere and don't move it for a while, because it's lost that kinetic energy, it no longer has the energy to keep that sediment suspended, so that sediment's going to settle to the bottom. And then bed load, the last one, this is stuff that it's just pushing along the bottom. So as water's flowing, it's just pushing it along the bottom, and things are bouncing into it and colliding with them. That's why river rocks are smooth and rounded, is because any sort of point or sharp edge or anything like that has been broken off. It's been worn away, and it's been eroded. So um, that's why river rocks are round and smooth, and they don't really have sharp edges on them too much, because all those have been broken off. And if they do, or if they do have that, then that rock hasn't probably been in there very long, or not as long as the other ones have. So those are the three ways that rivers move sediment: solution, suspension, and bed load. Um, the the carrying power of a river, or how much sediment it can carry, how much it can move, and how large the sediment is that it can move, um, is dependent upon a couple of things, and it is influenced first by speed. So the faster the water is moving, the more sediment it can move, and also the larger the sediment can be that it'll move. In a couple of examples, like go to a car wash. Go to a car wash. There's high pressure, water spraying on the car, because that has more energy, that can move more material. It can move larger material, as compared to just a garden hose or something like that. Um, Also, I mean, even just if you're washing dishes at home, if you're washing dishes and you've got, some dirty dishes or pots and pans and things like that, you're going to, use a decent flow of water, probably pretty close to full blast. You aren't just going to have it just trickling out, just little drips and drops. That's not going to move anything. So the faster the water's moving, the more sediment it can move, and the larger the sediment can be. And then the second one, discharge. So just how much water there is, which, I mean, makes sense. If a certain amount of water can move a certain amount of sediment. If you have more water, then it can move more sediment. I mean, it's pretty logical. So, a bigger river is going to be moving more sediment than a small river, just because there's more water going through it. This next one, well, these next couple, they're really only a couple of terms to kind of focus on this. And this diagram, it just kind of shows kind of the stereotypical, kind of a life cycle of a river, from the formation of it, where it starts up in its headwaters in the mountains, down to the delta where it meets, the river meets the ocean. So it goes from a small stream or creek or river in the mountains that's probably fast moving because it's in the mountains, so it's going to be more of a slope. It becomes a tributary and joins in to a larger river, and then that's going to become a tributary and join into a larger river. Then eventually, as it's a mature river and it's gotten down to its base level, which is when the river has pretty much gotten down to bedrock, then it starts to kind of move around a little bit, which we'll talk about in just a minute. It's moving more slowly, but it's larger. It's the width and size of it is much larger than it used to be. So again, the bottom two, the base level and the tributary, that's kind of what I would focus on those, or on that diagram at least. This next one, remember we talked about fast moving water creating V-shaped valleys. Again, if it's fast moving water, it's going to be able to move more material. It's going to move more sediment. So that's why it's creating these V-shaped valleys, because it's it's cutting into the earth more, and it's removing and eroding that sediment more quickly. So it's cutting in more effectively. As the river becomes older, then you have a floodplain start to form. It's getting down closer to its base level. It's getting closer to bedrock. So it's starting to move a little bit. Some bends and curves. And then in the old age or very mature river, you have lots of curves, lots of bends. It's not moving nearly as quickly, but it's much more mature as far as rivers and bodies of moving water go. The next thing, river systems. So these first two terms, drainage basin and watershed, they mean the same thing. It's just an area where all of the running surface water, all of that area, all of the running surface water goes into one river at some point. So in this diagram of Indiana, this white area, all of the running surface water in that area eventually will go into the White River, which is the river that's shown here. There's the two branches of the White River. So, if any stream or creek or anything like that eventually will end up in the White River. Now, outside of it, in the purple, those surface running bodies of running water, they're going to go somewhere else. They're going to go to a different river because it's a different river system. So like north, that's going to end up in the Wabash. And then the south is going to end up in the Ohio. The reason that that happens, why they're kind of separated, is because of divides, which is just kind of a high point in the land where, if water's on one side, it stays on that side. If water's on another side, it stays on that side. It doesn't go from one to the other. So that's kind of the drainage basin. And a basin, just in general terms, is a term for a depression, or like a sink can be called a wash basin. Um, so this drainage basin is just kind of, it's a low area where all of that water in that area, converges into, at one point, um, one river. And this next one, I don't think you have this one. This shows the drainage basin for the Mississippi in the upper left, which is a huge area of the United States. So, any surface running water in that whole area eventually is going to end up in the Mississippi, um, and then go to the Gulf of Mexico, through New Orleans. And you can even start way up here, in Montana, in some little river, and you can kind of follow it, and then it becomes a tributary and joins with some other river, and then you can follow it all the way down. So you could, if you had the time and the desire, all the way up into Canada. You could get in a canoe or something, and you could travel downstream all the way to New Orleans. If you just follow the flow, pretty much. Um, but it's a huge area and a huge amount of water. And then this other picture, the diagram, this shows different divides within the continent. This big red one is called the Great Divide, or the Continental Divide. It runs through the Rocky Mountains, which is kind of the western boundary of the watershed for the Mississippi. So anything west of that's going to go to the Pacific. Anything east of that's going to go into the Mississippi, into the Gulf of Mexico. Right. All right. So whirlpool action is something that's found in young streams and young rivers. And it's kind of a collective term for different features like potholes, rapids, waterfalls. And these are things caused by formations that are still underwater, like the rapids. And these are some people that are whitewater rafting. So it's called whitewater because it has air mixed in. And the reason it has air mixed in is because the water isn't flowing smoothly. There's stuff underwater, like rocks, that the water has to flow over. So it creates a lot of turbulence, and air gets mixed in with the water, and it creates whitewater. So if you see water like that, you know that it's fast moving. You know that there's stuff underwater that you can't necessarily see, but that's affecting the flow of the water. It's typically fast moving. The reason you see this in young rivers is because in more mature and older rivers, all of those things that are creating that turbulence and that the water has to flow over and flow around, all that stuff's been eroded and washed away. It's been broken down and that sediment's gone. But in young rivers, that stuff's still there. There just hasn't been enough time for that to happen. So it kind of leaves you with some of these features of the younger rivers. Something that can also show up in rivers is with waterfalls. And waterfalls actually move over time. They don't just move anywhere they want, but they move upstream. So whatever direction the water's flowing, which would be flowing downstream, waterfalls move upstream. They do that through this process. They recede upstream through this process of undermining. So as the water is going over the waterfall, it's undermining and it's removing material that's under that rock that the river is flowing over. And eventually it'll get to the point where there's rock that's unsupported, and that rock will break off, and then that moves the waterfall upstream just a little bit. It causes it to recede just a little, and then that process just continues, and it slowly moves back upstream. So this is an animation. It kind of shows the um, I guess the progression of Niagara Falls as it regresses or recedes up the Niagara River. And then this is kind of where it's at now. There's a kind of island in between. We actually have two separate falls. Run through this again since it's free. So, and this is a more modern picture, obviously. So we have that island in the middle, and then we have these two separate falls. This next picture, it has these dates, and as you get closer to where the falls are now, the dates become much more modern. And this is the fall over here. It's not the other one. But the dates kind of correspond with a lot of explorers in this area, trappers, traders, that sort of thing. They started keeping records of where the falls were at different times. So there's now a formal record of where the falls were at certain dates, and it'll continue moving upstream. That process will continue. It's not fast. It's not a quick process, but it does happen, and it'll continue to happen. So as rivers mature and they start to get to that base level, and they form bends and curves and all that, we call those meanders. So if something is meandering, it's just kind of moving, not really with a destination in mind or a goal in mind. You're just kind of moving. Like an example that I'm sure everybody has experienced this. You go to the store or someplace, and whoever you went with, they're still doing whatever it is they're doing, shopping or whatever, but you're kind of done. You're kind of over it. So you're just kind of looking around. You just kind of wander over here, and you just kind of look at this, and maybe I walk over here and look at this, and it's just kind of meandering. You're just kind of here and there, but not a real purpose. Not a real destination in mind. That's kind of what these rivers do. They curve and they bend. And here's an example of some meanders. This is in Indianapolis. So there's Keystone, and School would be up north of where this map shows, but there's like 80th Street there. But notice these curves. You have curves in the river. Now, of course, we go to great lengths to make sure that the river doesn't move around too much now, because there are buildings and roads and bridges and houses and all sorts of things that are built around the river. We don't want the river to destroy. So now we try to keep it where it's at. But if Indianapolis wasn't there, and if this was just in a place where there weren't a lot of people, then if there's just farmland or whatever, then the river would meander. It would change course slowly over time. The way that happens, or the reason that happens, is all because of erosion and deposition. So we've talked about erosion quite a bit. The sediment that's created from weathering is moved somewhere else. So water is the biggest thing that does that. And that's what we're talking about here. And then deposition, which we've talked about before, when that sediment is dropped or it's left, because the water that's moving it just doesn't have the energy to keep moving it. So it drops it deposits it. So with a river, as a river starts to curve and bend, on the outside of the curves, the water's moving a little bit faster. So on the outside of the curves, the soil and the rock and the material there is eroded. On the inside of the curves, the water's moving a little bit slower. So because it's moving slower, it doesn't have the same amount of energy. So there's deposition that takes place on the inside of the curves. So on the outside of the curves, you have erosion. On the inside of the curves, you have deposition. So anytime there's a curve, that curve kind of becomes more exaggerated because it's it's constantly wearing away at the outside of a curve. So the river is going to start moving, and those curves are going to get more exaggerated. So eventually they'll form these cutoffs. So if you have a curve in it, like I said, those curves become more exaggerated because it keeps wearing away at the outside. Eventually, where this is land, it's going to cut that off. It's just going to cut across it and join up with that other portion. Eventually, what can happen is that fills in with sediment and isolates this little body of water over here, which we call an oxbow lake. So this was a meander at one time. The river used to flow from its main channel into this meander and then continue on. But then that cutoff formed, and sediment filled in, which isolated this oxbow lake. And eventually it'll dry up, because there's no new water that's feeding it and replenishing um, water that's evaporating and all that. But it just takes time. The reason that it's called an oxbow lake, so an ox, which I'm guessing is kind of like a cow. Use them a lot on farms, especially in certain places, certain areas of the world. Um, so they're really versatile animals. You can use them for plowing fields, for pulling wagons, carrying just material. To pull things like plows and wagons and all that, they put this is the ox, they put something over its neck that's kind of like a horseshoe shaped, and that's called an oxbow. So that's where the oxbow lake gets its name from, is because it's shaped like that thing that they put over the ox's neck that you hook up, like I said, like wagons and plows and whatever else too. So yeah, fun fact for the day. I think we're gonna stop there.
Did you go back one slot?
I can.